Thanks. So I will talk about also a CNCF sandbox project. It's called KCP. At the beginning, I will talk about the project in general, then about some features of it, and then I will show two use cases. So my main approach will be that I will show what this tool can do or it's supposed to do, and then try to find some use cases to leverage those. So a first step after the Kubernetes introduction from István in the previous section, I'd like to start with a typical Kubernetes clusters layout, just to consider how KCP is different from that. So typically, Kubernetes cluster consists of an API server and an etcd or etcd. They talk directly with each other, and they are the two components who talk with each other. Or API server is the only component that talks directly with the etcd. And the API server itself takes care of basically the CRUD operations of Kubernetes resources, which can be either some built-in resources like namespaces, config maps, secrets, pods, deployments, nodes, services, and such, or they can be custom resource types that are defined by the user via CRDs or custom resource definitions. This API server also provides some features like role-based access control, and it also has some business logic related to the built-in types, less and less as Kubernetes itself developed, because there are some external components of a Kubernetes cluster. Two big blobs of it are managed by the Cloud Controller Manager and the Kube Controller Manager. The Cloud Controller Manager is specific to the cloud where a Kubernetes cluster runs. It takes care of services, nodes, and routes. These are the most important controllers within that groups. For example, if you have Kubernetes cluster in AWS, the service controller will create the network load balancers for your Kubernetes service resources, and of course the node controller can take care of scaling up or starting nodes based on your cluster and so on. The other part is the Kube Control Manager, which I think István has already mentioned. So it has things like the deployment controller, node lifecycle controller, job controller, and so on. So these are basically controllers which, for example, in case of the deployment computer, it watches deployment resources in your cluster, and based on that creates replica set resources. So all these together take care of the business logic or the internal workings that we are used to in Kubernetes. The other big part is running on the compute nodes themselves, where the most important part is the kubelet, which is the agent that watches your most importantly watches your pod resources, and based on that it will launch, delete, and manage containers. Other than that, it will also take care of some networking issues, and it's accompanied by the kube proxy, which takes care of exposing services on the nodes. So, what's the difference between typical Kubernetes and KCP is that they removed everything that relates to the traditional workload-related resources in Kubernetes. So they removed the Cloud Controller Manager and the Kube Controller Manager. They removed almost all of the built-in types, so there are no pods, deployments, nodes, whatever. They also removed the kubelet, kube proxy, the scheduler, so everything that takes care of orchestrating workloads and managing those. What remained is basically the API server and the etcd. The API server, as I said, no longer contains the workload-specific built-in types, but it is still a Kubernetes compatible API server, which has the basic built-in types like the config maps, secrets, the RBAC related resources, also the CRDs, so you can define your own types, but no nodes, pods, deployment, etc. Because it is a Kubernetes compatible API, it also means that you can continue to use kubectl to manage the resources. But of course, if you try, for example, to list your pods, it will tell you that it never heard about a resource type called pod. But other than that, you can use in the kubectl in the usual way. You can even continue to use some controllers. I think a great example is the cert manager, which with some configuration but not much. So no code changes can easily run on your cluster. You can deploy the CRDs, so you can create your certificate and such resources, and it will take care of issuing certificates, writing the secrets and whatever. You can also use the usual SDK tools like controller runtime and kube builder. And you can continue to use your experience with Kubernetes, given that it exists. This looked like it's too simple, so the KCP team created a POC where they removed all those things, but they felt that the code is too small, so they have also added some features in the place of those. Where the most important one is the concept of workspaces, which basically means that just like with namespaces, you can quite easily and cheaply create new workspaces. So you don't have to spin up new Kubernetes API servers or even etcd clusters. You will get a separate Kubernetes API. And I will talk about all of those in more details. The other thing is a concept called API exports and API binds, which is a solution for providing and consuming services, or services in the sense that controllers or operators usually do to other tenants of the system or other workspaces. They also added, at least to some level, a solution for sharding, which helps in scaling the system up. And they also have a Workspace aware Go client, which is basically a fork with a quite small change set of the original Kubernetes Go client. You will get a quite simple Helm chart, and of course the container images with it to deploy this stuff to a regular Kubernetes cluster. But for testing or development, you can also use an all-in-one single binary. So you can issue a command like KCP start, and you will have something that's a Kubernetes compatible API. And also they have a kubectl plugin. And I think quite obvious question is, but why? So why did they remove the workload things? I can understand those, but I can't easily understand why exactly those features were added to it. And the interesting thing is that if you check different presentations about the project in time, every time they say something different about the goals of the project. But I think because they are already in the CNCF sandbox state, they had to finally come up with some goals that everyone can believe, and I hope that they won't change it significantly just for the sake of changing it. So anyway, one interpretation of the current project goals is that they want to provide a generic control plane for applications. And my understanding about the applications that can benefit from this is that if you happen to have an existing operator controller that uses Kubernetes but not the workloads stuff, and you may want to continue to use without it and even extend it to multiple tenants, then it's a good match for you. I think most of the use cases are somehow related to IT infrastructure, but we also heard an idea about controlling satellite dishes, but it's also infrastructure. So I think I wouldn't like use it for I don't know, the guest book of web page, because we do have SQL or whatever database you believe in, but things in this area are a good candidate for this system. If you happen to have a system where the end user wants, you want the end user to specify a declarative state of or the desired state of the whole system, then these Kubernetes-like patterns will help you there. The other goal that the KCP project owners repeat is that they will bring the SaaS to Kubernetes. And I will try to interpret this in later. And the third goal was that they want to implement multi-tenancy with something like Kubernetes, or I don't know. The goal here was that they want a system that works with 1 million workspaces. So these features, the workspaces are quite similar to namespaces, but different in many ways. So the most important part is that workspaces are cheap, so you can create them just like a namespace, single API call, single API, Kubernetes resource, and it's there, so you don't have to spin up clusters or something that would make you try to cut the number of those. It provides a quite different level of separation compared to namespaces. The first thing is that Kubernetes namespaces were added to Kubernetes in the early days, but not in the very beginning. So the main goal was there that they want to prevent name collisions between different resources. So instead of prefixing with the namespace name your resources, you have an easy option for that. And of course, later, as most of you know, you can also use the role-based access control on a namespace level, but that comes with some restrictions because some of the Kubernetes resources are cluster level, so there obviously you don't have any kind of separation. You can restrict the use of those, but then, for example, you can't install a new operator which uses CRDs or whatever. Another important difference to regular Kubernetes namespaces is that workspaces support hierarchy. So you can create workspaces within workspaces. Of course, all of your workspaces will include namespaces because they are basically a separated Kubernetes scope or cluster scope where you can use namespaces. I would note that there are different solutions to do something similar. So, of course, you can use name prefixes again for your namespace names. You can use labels, and also there is an extension to the namespace model called hierarchic namespace controller. And the other thing I wanted to mention is the difference between the REST API. So namespaces are part of the normal URL where you can I won't try to find it. Okay, so they are part of the URL, but workspaces are a prefix to a whole Kubernetes API endpoint, which means that basically you use them in a way that you can define different Kubernetes contexts in your kubeconfig file with the bold part of this URL as the URL endpoint. And basically, a workspace will behave the same as an independent Kubernetes API server would. There is a kubectl plugin, as I mentioned. One of its shorthands is this kubectl WS, which is basically short for kubectl KCP workspace. Basically, you will have some commands after that at the end of this. So, for example, you can run kubectl workspace 3, which shows my root workspace and the 3 leaf namespaces within it. But you will also have a create command, so you can create, in this example, the workspace called new. So the underlined part is not a command, it's the name of my workspace. You say --enter, which means that you want to immediately rewrite your kubeconfig with a new context that uses the new workspace. And you can issue regular Kubernetes comments in it. So in this example, I created a namespace in the new workspace. You can also use this exact same command with a similar way, like the cd Unix command. So I now moved back to my root workspace, and then I listed the existing workspaces again, so you can find the new one there. And I will enter into a different one, so not the new, but the user. And of course, if I list the namespaces, then I won't see the my NS, which I created in the other workspace. So this is how you walk around. Sharding is an important design feature of KCP, but it still needs work for production use. I think their original design goal, so at least one design goal was that they want to handle 1 million workspaces. For example, if you consider use cases with IoT involved or edge computing or whatever, it might make sense to have independent workspaces for so much different tenants or whatever use case you have. And obviously, a single cluster with etcd and a few instances of the API server won't handle that scale. So they came up with the concept of shards and some other resources where the shard describes basically a set of things they call logical clusters, whatever that means. And in those logical clusters, you can have workspaces. So you've seen my root was called like this KVD whatever. That's different in the Kubernetes clusters because at the end you may have to merge those together, and that's why it's random generated. Earlier it was root always. If you define those shards, then you can deploy multiple instances of KCP with a component called front proxy in front of them. And this front proxy is supposed to know about all of the logical clusters, shards, and thus the workspaces in all of your KCP instances. And based on that, they tell that it proxies you to the other instances. I believe it's more like a redirect, but basically it seems like this implementation is just a POC in its current state. Another thing is that if you have controllers that work against multiple workspaces, unlike in a single cluster setup, they will have to watch multiple endpoints. But these shard and logical cluster and workspace resources are supposed to help with discovering the right endpoints. And we are coming to the other concept that they have added. So the original promise is offering a way to consume and offer software as a services to your tenants, which basically means that you can use a single tenant as the service provider, where you can run multi-tenant or multi-workspace controllers, which export an API, where the API basically means a CRD. so in that sense, API, and with this modified Go client and the SDK, you can write controllers which will be notified about changes of your CRD in all of the workspaces on this KCP instance when the other tenant subscribed for your services and provided the needed permissions. So the other part of this is the API bind feature, where basically you can bind to exported APIs, which means that the tenant who exported that API will be able to access the exported type of resources, and that in turn means that you can consume the service provided by a different tenant. This looks good, but it only works if you are using the same KCP instance or system as the service provider, and this is where a project called kubebind comes in, which tries to make this make this work between more clusters. So if you install this stuff and set it up properly, then you will be able to consume these services even from your regular Kubernetes cluster. The sad part is that this seems more like a POC for a conference speech rather than a maintained project. So we try to show a quick example. This is the official example for multi-tenant controllers. So in this case, we have a simple CRD. I will show this through an example. So basically, we have a custom resource definition called widget, which has a spec with a single field called foo, which is a string, and the status sub-resource, which has a single field called total. The latter one is an integer. You will have basically a what's that? The controller runtime fork. So you can use the well-known SDK for defining multi-tenant controllers, but with some small modifications. This is basically an abstract of the reconcile loop of this example. So I've removed many things, but the important ones are there. So the first thing is that they pass the name of the actual cluster that owns that resource in the context. In this request object, which the reconciler uses. You can add this to the context, and based on this context, you will be able to use the usual Kubernetes client to get resources from the user's clusters. So this is, in this part, we are simply getting the object that triggered the reconcile. Then we also list all of the widgets in that cluster, so in the user's tenant. Then, for the sake of the example, it counts the number of widget resources at that user. If that's the number which is in the status part of the resource, then it quits. But otherwise, it patches the original resource. So basically what will happen is whenever you create a new widget resource in your cluster, then the status will be patched with the total number of your widget resources in all of them. Okay, then we will enter a workspace called controller, which is different from the one that we will use to consume this service. We will have to find the ID of our logical cluster. We will need this later. And this is the usual kube builder makefile, so you can install your manifests, which in this case is not a CRD but an API export and an API resource schema. The first one defines this service as a whole. The second one is basically a version of the CRD. So as you said in the example, they called it today. That's the part where you name your version. It should be something incremental, I think, but that's the example. And you simply run that controller. From different terminal, we enter another workspace, which is of course different from the one where the controller runs, and we use the kubectl plugin to bind the API export. This is where we had to define the ID of the logical cluster, and this data.my.domain is the name of my API export. And after that, I can already use that type. It doesn't appear as a CRD. So, for example, you can't even use kubectl explain to find out what are the fields, but and anyway, you can create instances of that type. In this example, I created one called W1 and another one called W2. And right after it, if I list those widgets, you can see that the status.total field is already filled in by the controller. So basically, that's the API export and bind feature in short. Then there was an integral part of KCP called transparent multi-clusters, which was about giving back the workload stuff to KCP, but not directly, instead of that with remote clusters. That means that you won't have resources like pods or nodes, but you will have deployment services and so on. And this TMC, Transparent Multi-Cluster Controller, will take care of distributing those into clusters that you bind with the help of a syncer module. So as I said, this was part of KCP, an integral part, and in May they removed it. The code exists in a different repo. But based on that experience, there is a project called Kubestellar, which uses KCP and does something similar to this TMC. So it's worth checking out. The example with the original TMC controller is that you create a special type of workspace, then you create a manifest file for registering a regular Kubernetes cluster into it. Then you apply this manifest to your Kubernetes cluster, and then a similar command to the API export bind, you can bind it, which will create I think a compute bind resource. After that, you can create basically you can create deployment resources, and in the background it will take care of placing those. There are other resources that specify how, so you can define like placement, and I don't remember the other one. So it's not just random. And then I will run through quickly on two use cases for this whole system. The first one is what we are using it for at Axoflow. So the main domain, and also Pepov had a presentation about that at the previous session. So I think that was also in May. So we are managing log metrics and traces in a distributed system where the system is dynamic. So you will have systems coming and going. You will need things like auto-scaling, self-healing, and you will want your users to be able to define a desired state of a whole telemetry system, or I mean in a sense global to the organization. And for that system, we use KCP as the backbone. For example, we have resources like host, which describe a single host, similarly to the node resource of Kubernetes. We also have an agent that's called Axolet, which does something analog to kubelet. So it watches its own namespace, its own host, and based on that, it will apply the desired state of it. And of course, it also reports the status of that host. I think I can't tell this without more details. The other more general use case for KCP is testing Kubernetes controllers or operators. So automatic testing of Kubernetes causes some issues. One of them is that you will need cluster level permissions for updating CRDs. And that not only means that the permissions are too high, but also that basically you will need a dedicated cluster for each parallel CI run of a controller's tests. And if that given controller creates resources like persistent volumes or services or even pods, it might become quite slow, unreliable, or costly. And this is where KCP can help. So the idea is that you run your test targets, so the controller you are testing in a regular Kubernetes cluster, but you set it up to use the KCP as the managed Kubernetes API. So instead of the local service account, you give it a kubeconfig, and then you can create a dedicated workspace for that specific test run, deploy your CRDs in the desired version, run your tests. You can even implement mocks for the workloads. You can do this even with the API export functionality, or you can do this from your test execution based on the scenario. So, and at the end, you can simply drop the workspace. And now the conclusions. So I think KCP has many possible applications. Most of them will be new to the original team as well. They have a quite active community. They are now part of the CNCF Sandbox project, or they are a CNCF Sandbox project. I think workspaces are the part that work without any issue. Of course, the service itself seems to work well. Other than that, API exports are useful. I think they need some refinement for that to be really useful. But the development itself is still in an early stage. They do breaking changes even in the etcd schema, so the update instructions for the version before the current one was that please drop your etcd and install it. I think their release testing scope is limited. So we have found regressions there, but they quickly fixed the memory leak issue. As I mentioned, the fundamental goals change from time to time. And the most important part is that the documentation is non-existent or worse. So they are basically all of their documentation pages are under the subsection called concepts, which means that they are like planning documents which are either implemented, not yet implemented, implemented differently, or no longer in use. So I promise that I will show 4 different features of KCP that I was quite confident that exists and works, and one of them worked after like 1.5 days of trying. I didn't have time for 2 others, and the 4th one is removed from the project. So I like the idea, and I hope that this active community will make it even better. And that's all from me. Yes. Any questions?
Do you use it in production? Is it production ready?
It depends on what we call production. So it is part of our main product, which is not yet publicly available. We have plans to replace it if we have to. So we don't really use any KCP-specific features that can't be replaced with something else. We hope that the project will develop quickly.
So I already love Workspaces. It solves a real pain point of us. First of all, do I understand correctly that you forked the original Kubernetes API server and added Workspace support to that? Is this
I think KCP itself is a separate project or repo which uses forked versions of the Go client, all the libraries that are used or part of the Kubernetes repo. So they basically have a quite small change set. They were able to rebase it from 1.16 to the recent ones. So a small change set and some independent code together.
That's nice. So my actual question is, if Workspaces and API exports and all of these become stable, are you planning to upstream it? So to push it upstream to the normal Kubernetes API server? So do you think that would it Kubernetes API side?
I'm sure that it would be useful. I'm not
I
at
would love
I'm not at all sure about it really becoming part of the upstream Kubernetes.
But is there a technical problem, or you don't think that the community will accept it?
I don't think the community will accept it. There are different solutions for the same problems, and none of them is becoming like official one.
Yeah, but this is a good one. So we have a lot of bad solutions for the problem, and this is a good one for
That's
if
the
you ask me.
community. There are different solutions. Everybody likes some of them.
I know, I'm just kidding, but okay.
Yeah,
But
there
is there a technical issue with upstreaming workspaces from the KCP API side?
On the long term, I don't think so. On the long term, I don't think so.
Okay, thank you.
And
That's all.
we are in Solo.io, Blue Mesh, it supports workspaces. Solo.io is like a service mesh stuff.
Oh, I see. Okay, I don't know it, but I will check it out.
Yeah, Blue Mesh.
Okay.
That
Okay.
includes workspace stuff.
Thank you.
Stuff.
And thank you. And just a note that we have, of course, there is the project page, but the other one is a blog post about our use case and the general topic of using it as a declarative control plane. It's worth reading.
I'm not deeply well versed in management plane solutions, but I have heard many from the cloud native community, such as crossplane, for example. If you had only 1.2 feature, which is let's say heighten up this project from the others, what would be?
To be honest, I don't know all of the other ones very well. So I think that now, so the latest version of the goals, KCP focuses on this generality and like crossplane does have a specific use case in mind. You can extend it, just like you can extend Kubernetes to whatever you want. But I would say that this focus for the user-supplied use case is an important part of it.